with Mrs. Miller at BVISD. So we're going to be focusing on acids, bases, and pHs and some salts. Now, what I want you to remember is this is a long chapter and it can be a little convoluted. So please bear with me and remember that sometimes we're going to have some videos that seem a little disjointed. But what we want to be able to do by the time we're done with this is distinguish acids from bases by their properties, relate acids and bases to the reactions in water, and evaluate the central role of water in chemistry of acids and bases. So what is an acid and what is a base? Well, basically, when we use the pH scale, acids are 0 to about 6.5. At 7, we become neutral. At 7.5 to 14, we hit bases. Now, typical base that you would have in your kitchen would be a baking soda. Typical acid that you would have, a lemon. Now, acids produce hydronium ions, H3O plus ions in water. Bases actually produce hydroxide ions, OH negative. That is the chemical definition of them. So let's look at some properties. Here, if I can find the properties. Okay. Vigorously reacts with metal to produce hydrogen ions. I'm sorry. I'm pulling up too at the same time. There we go. I'm trying to find the one. I apologize. Tastes bitter. That would be bases. Some other properties that we look like: vigorously reacts with metals to produce hydrogen. That would be acids. Turns red litmus paper blue would be bases. If I can find that again. Tastes sour or tart and does not react vigorously with most metals would be a base. Feels slippery and smooth and turns blue litmus paper red would all be, whoops, get that one. You got to get it right on the spot, otherwise it goes back. Okay. One more here. Turns blue litmus paper red would be bases, although I can get it pulled up here. Feels slippery and smooth, bases. Now, acids. Basically, they taste sour. You're looking at tomatoes. They're a pH of 4. They're electrolytes, which means they can conduct electricity, and they are corrosive. They eat away at metal compounds. So we talk about battery acids. Okay, they do react with indicators in an organic compound that changes color depending on if it's an acid or a base. So litmus paper turns red with acids, and with phenylalanine or pH indicator, it turns colorless. Now, examples of some acids every day. That would be lemons, has a pH about 2, aspirins of 5, vinegars of 4. So the lower the number, the more acidic it is. Now, only a base can neutralize or weaken an acid. So all acids range from a 0 to a 6.9. Obviously, the 0 being very, very acidic. Now, we want to be able to name some acids and salts. Oh, crap. Might as well just shut that off.